Okay, so we're going to continue with solving a 3x3 system, which we would have 3 equations with 3 variables. So instead of using substitution like we did on the last lesson, we're going to be using elimination. So remember when we went over a 2x2 elimination, we're trying to eliminate one of the variables. So our first step with using elimination is to select a variable to eliminate. It doesn't really matter, but notice here that these y's automatically cancel. So I'm going to eliminate my y values. Okay, so we're going to combine any 2 equations. So I'm going to write the top equation and the bottom equation, and I'm going to add them up. So that's 3x, the y's cancel, plus 2z equals 25. Okay, so now the next step is to combine a second set of equations, and you are eliminating the same variable. So very important, make sure you're doing the same variable. So now I'm going to eliminate y's again, but I'm going to use the number 1 equation and number 3 equation. So I'm writing the first one down, and I'm writing the third one down. I'm adding them up. That's 2x, the y's cancel, plus 2z equals 8. Now, notice that, remember we discussed this on the 3x3 substitution. If you can divide all of them by it, you can reduce the equation. So that would be good. On this one, we can eliminate or divide by 2. That's x plus z equals 4. So they all have to be divisible by the same number. So that's why we couldn't do that on that first one. Okay, so now we're going to solve the new 2x2 system for both variables. So I'm using this equation and this equation. So we want to eliminate a variable. It does not matter which variable. So I'm going to eliminate the z's, and I'm going to multiply this one by -2, since that z is a 2 there. Make sure you distribute it. That's -2x minus 2z equals -8. And then I'm going to rewrite this equation here right below it. So combining those, we get x, the z's cancel, we do -8 plus 25, which gives me 17. Okay, so we found x equals 17. So once you find that, I would plug it back into either this equation or this equation to find your other variables. So I'm going to use this one. X plus z equals 4. So I'm going to plug in. We found x to be 17. Subtract 17. And you get z equals -13. Okay, so once we know x, z, we will have to plug back into one of the original equations. So it doesn't matter which one. I'll just use the top equation. So I have x plus y plus z equals 0. I already know x is 17. I don't know y, and I know z is -13. So I'm going to combine the 17 minus 13. So I would have y plus 4 equals 0. So then I would have to subtract 4 to get y equals -4. Make sure you're writing your solution as an ordered triple. So x comes first, 17. Your y is -4. Your z is -13. To check it, do it the same way. Plug into all 3 equations. Make sure it's true for all 3. So this is solving a 3x3 systems of equations using elimination. Let's take a look at the back. Okay, so number 2, we're using elimination again. So you pick a variable to eliminate. It does not matter which variable you eliminate, so you get to pick. I notice that the b's automatically cancel. So I'm going to go ahead and combine the middle number 2 equation and number 3 equation, because I know they automatically cancel out here. So adding them up, we get 4a, the b's cancel, plus 3c equals 20. All right, so now step 2, you're doing the same thing and eliminating the same variable, but you have to use two other equations. So I'm going to use these top two, but I would have to multiply the second one by a 2. So that would be 2a plus 2b plus 4c equals 30. So I multiplied that second equation by a 2, and then I'm bringing down that top equation right below it. So you should be eliminating the same variable on step 1 and step 2. So notice my b's cancel. I get 8a plus 6c equals 40. Notice here we can simplify this equation by dividing it all by a 2. So that's 4a plus 3c equals 20. Okay, so after I simplify it, notice here, these are exactly the same. When they're the same, they have every point in common. So this would be infinitely many solutions. Now, if you don't reduce it, you're not going to realize that, so you're going to have to use elimination and eliminate either the A's or B's, A's or C's, and then you would realize that both cancel out. You have a true statement. So it's really important, if you reduce your equation, it's very easy to see that they're the same equation, and that means they have every point in common, which would be infinitely many solutions. Okay, so number 3, we need to pick a variable to eliminate. It does not matter which one. Notice on my second equation, there's no x, so I would eliminate x. So I'm going to use the top equation, number 1, and number 3 to eliminate the x's, since number 2 does not have an x. So I need to multiply the top one by -2. Make sure you distribute it to everything on that equation. Okay, so then I'm going to rewrite the third equation. Notice x's cancel, y's cancel, z's cancel. I get a 0, and then adding these we get -20. 0 does not equal -20. So this is a false statement, which means if all of your variables cancel, you have a false statement. There is no solution, which means they do not have any points in common. All right, the last one, we're given a word problem. We're going to actually have to come up with our system of equations ourselves, and then we can use elimination, because that's what it tells us to use. So Alan has $47 in 12 bills in his wallet. It includes ones, 5s, and 10s. He has 2 more $1 bills than the combined number of 5s and 10s. How many of each denomination does Alan have in his wallet? So whatever you're trying to find are your variables, so you need to define them and tell me what you're using for each one. So I'm just going to say X is going to be the number of $1 bills, and then Y is going to be the number of $5 bills, and Z is going to be the number of $10 bills. Okay, so we know we have a total of 12 bills. So if I add up the number of 1s, the number of 5s, the number of 10s, it gives me 12 because there's 12 bills. It also gives me the actual value, $47. So I know each dollar is worth $1, so 1x. Each 5 is worth 5, so 5y. And each 10 is worth 10, so 10z. That would give me the total dollar amount, which is $47. Okay, I have to come up with one other equation, because remember we have to have 3 equations, 3 variables. So the last one, it says if he has 2 more 1s, so my 1s are x, 2 more than the combined number of 5s and 10s, so y plus z, that will give us the number of 1s there. Okay, so we need to use elimination, but notice that my third equation has just one variable, and then the other variables are on the other side. So I need to put it in standard form, which means all of my x, y's, and z's on one side, my number on the other, constant. So I'm going to rewrite this as x minus y minus z equals 2. So those are the same thing. I subtracted y over, subtracted z over. Okay, so I want to eliminate a variable. It does not matter which one we eliminate. So let's see. Let's eliminate the y's, because I noticed this top one, this bottom one, the y's will automatically cancel. So I'm going to write the top equation. I'm going to write the bottom equation. So combining them, I get 2x, the y's cancel, the z's also cancel, and that gives me 14. So I can automatically solve for my x, which is the number of ones, which would be 7. Okay, so now I had said that I wanted to eliminate the y's. Now I need to go through and eliminate y's again on the next step. So I'm going to use this equation and the second one. So I would have to multiply this third equation by a 5. 5x minus 5y minus 5z equals 10. And then I'm using the second equation that we wrote. Combining them, we get 6x. The y's cancel. I get plus 5z equals 57. Okay, so notice we already found x, so now we can substitute it in here in order to solve for z. So that's going to be 6 times 7 plus 5z equals 57. So that's 42 plus 5z equals 57. So subtract 42. 5z equals 15. So z will equal 3. Okay, so we know x, we know z. Now we need to plug it back into one of our original equations. It doesn't matter which one. I'll use the top one. So x plus y plus z equals 12. I already know x is 7. I don't know y, and I know z is 3. So combining them, you get y plus 10 equals 12. So we know y has to be 2. Okay, so when you are solving a word problem, make sure that you actually tell me what it means. So we know the ordered triple would be 7, 2, 3, but I want you to explain it. So there are 7 ones, $1 bills. There are 2 $5 bills, and there are 3 $10 bills. To check it, you can easily plug those back in and make sure that it's true. If you have any questions, please let me know.